This video lesson coincides with section 6.5, the remainder theorem and the factor theorem. Specifically, we're going to be looking at long division of polynomials and synthetic division with polynomials in the accompanying video. So for a quick reminder of long division with real numbers, I'm going to divide 284 by 3. So we ask ourselves, 3 goes into 2 how many times? Well, it doesn't go into 2 at all. So I look at the next string of numbers, 28, and I say 3 goes into 28, well, 9 times. 9 times 3 is 27, and then I subtract down. I now bring down the next number, 4, and I make this 14, and I say 3 goes into 14 4 times. 4 times 3 is 12, and again I subtract down. 3 does not go into 2, and there's no other numbers to bring down, so 2 is my remainder. And I said the answer is 94 and 2/3. I'm writing it like this. This is unusual for real numbers, but I'm writing it like this, 94 plus 2/3, as in 94 plus the remainder over the divisor, as this will be helpful when we look at division with polynomials. Okay, on to polynomial long division. So I'm going to divide 2x cubed minus 5x squared minus 2x minus 3 by x minus 3. And when I do that, I'm going to set that up in the same way that I divided 284 by 3. And I'm going to ask myself similar questions. X times what gives me 2x cubed? Notice how I'm not concerned with the minus 3 here, and I'm not concerned with any of the other terms that are out to the right. I'm just concerned with the first term here and the first term on this line. So x times 2x squared is what gives me 2x cubed. And now I'm going to multiply 2x squared times x minus 3, and I'm going to distribute properly and get 2x cubed minus 6x squared. Again, I'm going to subtract down. And when I do that, I'm going to be careful about the signs. This is negative 5x squared minus negative 6x squared. When I subtract down, I get positive 1x squared. And then I do the same thing that I did up here with the 284. I'm going to bring down the next term. I'm going to bring down the minus 2x. And then again, x times what gives me this first term here? Well, x times x is what gives me x squared. And then I multiply x times x minus 3, and I get x squared minus 3x. And again, I subtract down. Negative 2x minus a negative 3x gives me a positive x. And I bring down the next term. And again, x times what gives me x? Well, that's a positive 1. I take positive 1 times x minus 3, and again, I write that product down here, and I subtract down. X does not go into 0, so that is my remainder. And now my remainder is 0, so my solution is just 2x squared plus x plus 1. If this was a remainder of anything other than 0, what I would do is I would write my solution as my quotient plus my remainder over my divisor. Being that my remainder is 0, I would not need to write this, and I can just write the 2x squared plus x plus 1. But I did want to show this to you as the form that we'll see often, because oftentimes a remainder will not be 0.